Okay, so we'll be starting with our next topic on GPS, um, which has a broader name of GNSS, which stands for Global Navigation Satellite System. And GPS is just one connotation to it, and it's basically the American GNSS system, which is called as GPS. But overall, the whole operation is called as GNSS, Global Navigation Satellite System. So it started off in 1957, just a brief history. It works by sending and receiving signals from satellites. So you have different sort of satellites now. You have the satellites which are pretty close to the Earth, like the International Space Station, or you have the remote sensing satellites whose main purpose is to take pictures or to take some other sensing data. Some satellites can make profiles of the Earth. Some satellites are just there to take pictures. So there are various functions. We'll also cover some of those in the topic of remote sensing. And then at higher altitudes, you have the GPS satellites, whose main purpose is to send and receive signals from the Earth. And using those signals, we can identify the location of different objects. And by locations, you can then calculate speeds and a lot of relevant data. So you have those satellites, and even higher than that, we have the geostationary satellites, which whose main purpose is they're used for telecommunication. They're used for sending out those TV signals and all of that. So the satellites that we're talking about are the GNSS satellites. They revolve around the Earth, and they need to be in sufficient number for the whole process to work. We'll get to how the main process is, but it started in 1957. The Russians were the first to send out a satellite in space, and it was called as Sputnik. And what they saw was that because of the shift in the frequency of the signal, they could use the Doppler effect to find out the location of the satellite or to predict its orbit. And once they could do that, they discovered that there were numerous applications of the process. And then the Americans came in and they sent out the satellites. They even launched a program which was later on given the name of Navstar. So in 1996, the whole system was called as Navstar. It's functional today. Usme satellites numbers are around 24 to 32. The numbers keep on changing. But this is the whole picture. So they send out a number of satellites, and the number is chosen in such a way that on any location of the Earth, you should have at least four satellites that can communicate with you. कुछ ऐसी countries हैं, they have lesser number of satellites in space, uh, so that restricts the whole operations to any location on the surface of the Earth. For example, China has lesser number of satellites, but the satellites are positioned in such a way that the navigation system works within China. Those satellites are always available for people who are physically located in that territory. Like, if you want to cover the whole globe, then obviously the number of satellites has to be more because at any time you need to have at least four number of satellites. So currently, the navigation programs जो हैं of different countries, we have GPS program which is of USA. Then we have GLONASS, which is for Russia, Baidu for China, Galileo for European Union. Then we have one for Japan and one for India as well. इसमें कुछ limitations हैं. For example, GPS and GLONASS cover the whole world. I think Galileo as well, Baidu is in the process. But every country has its own programs. And your mobile phones also have GPS, built-in GPS. कुछ mobile phones में it gives you an option if you want to use the GPS, the American navigation system, or if you want to use the GLONASS, the Russian नेविगेशन सिस्टम ज़्यादा अभी यही हैं कॉमन, बाकी भी आहिस्ता आहिस्ता हो रहे हैं. So you can check, go into the settings of GPS on your phones and see if it gives you the option. If it doesn't, usually by default, your phones use the GPS, American system. लेकिन you can use both at the same time as well. उससे your accuracy increases a lot. So we'll be discussing these systems one by one, different countries, just to give you a brief idea. The American system it's called Navstar, or it's commonly known as GPS. So as of 2016, it had total active satellites of 31. The GPS does not require the user to transmit any data. It operates independently of any internet reception. So even if you don't have internet, your GPS would still work. Now, this data, these numbers are from 2016. So obviously, with time, things keep on changing. For example, if I talk about GLONASS की तो खैर पहले भी 24 से ज़्यादा थी. It's 100% coverage of the Earth. But if I talk about the Chinese, or if I talk about the Japanese, इनके numbers increase हो गए होंगे. With time, the numbers keep on increasing. अब इसमें the benefit is कि if you have a number of navigation systems, you can use different systems at the same time, and that increases the number of satellites that are accessible to you. So if there are four satellites at a time of GPS, and there are four satellites of GLONASS as well, so total जो आपकी accessible satellites हैं, they become eight, and that actually increases the accuracy of your GPS navigation system working. क्योंकि let's talk about the application and survey. अब एक होता है that you use GPS for navigation. You use Google Maps. उसके ऊपर you can have your live location. Based on that, you can get directions. So the live location that the Google Maps is giving you, it's giving you your latitude, longitude, and probably altitude. Google Earth पे भी ऐसे ही है. Now, that location is a little bit off. You must have experienced it as well. You turn on the live location, you would see on Google Maps that I'm standing here, but it would give you location probably a few meters apart. So and that's a limitation. उसके बाद you have handheld GPS devices. उनमें accuracy थोड़ी ज़्यादा होती है because the receiver is a little bit more sophisticated. Handheld GPS devices, we have one in our lab as well. You'll use that. Uh, that is also used for navigation. आप कहीं जा रहे हैं जहाँ पे सिग्नल्स नहीं है, इंटरनेट के सिग्नल्स नहीं है या कुछ इस तरह के मसले हैं, so you can use that handheld GPS device basically for navigation. उसमें भी the accuracy is off by a few meters. Mobile में if it's off by around 8 to 10 meters, उसमें it would be off by around, let's say, 3 to 6 meters. In survey, what we need is we need accuracy of millimeters, depending on the type of the project. So अगर आप कोई alignment कर रहे हो, if you're doing alignment for a project, उस case में you're okay with using an instrument that doesn't have so much accuracy. लेकिन if you are trying to set out coordinates of a building, or if you're trying to set out a baseline, उस case में you need to be really accurate to millimeters. So you cannot use the ordinary GPS which is in your mobile phones or which is available in the form of handheld GPS. वो आप use नहीं कर सकते. In that case, what you need is a more complex GPS device, which obviously costs more, but it uses some procedures and a more sophisticated system that gives you accuracy within millimeters or centimeters. So that is how you can replace your labeling instruments, theodolites, everything by using GPS devices, and that GPS can do the same work for you, and it can really pace up the work. क्योंकि उसमें you don't have to do any leveling or any adjustments. You just keep on taking the readings. It's really quick for you to take the readings. Another benefit is that you can work at night as well. बल्कि it's more accurate to use GPS at night than it is to use it in daytime. So that is why it has all of those advantages. Or secondly, it gives you your location directly in the form of latitudes and longitudes. So अगर आपने किसी और system के साथ उसको integrate करना है, it's very easy for you to integrate it. So if your project is not localized, if you have to match it with some other coordinates, then it really helps. So how does a GPS work? A GPS basically works by a process which is called as trial iteration. So इसमें होता ये है कि someone on the surface of the earth is using a GPS. So what that GPS device would do is that GPS device would um, interact through a signal with a satellite, and that satellite has atomic clock, and it can measure the time the signal takes from the satellite to your receiving device, which can be your phone or which can be a GPS device, and it can calculate the time that signal takes to travel between the two. And since the signal travels at a specific speed, the speed is known, the time is calculated by atomic clock very accurately. With that, it can calculate the distance between the satellite and any receiver on the surface of the Earth. लेकिन इसमें प्रॉब्लम ये है कि let's say the satellite is somewhere over here and the satellite says कि यार the receiver is this much at this much distance from the satellite. Let's say कोई भी distance है 20. इसका मतलब है that the receiver can be anywhere within 20 units distance from the satellite. So that means that your location is narrowed, but it's not pinpoint location. So this is where another satellite comes in. एक और satellite है, which does the exact same thing, and it says कि यार it's 10 units away from me. So that means again you make a circle like this at which every point is 10 meters. So now we have two intersections that the location of the receiver can be either this one or it can be this one. This is where the third satellite comes in, and the third satellite would again make a similar sort of a prediction of distance, linear distance, and the location where the three intersect, that point becomes the real location of the receiver. And similarly, if you keep on adding more satellites, this process keeps on getting more accurate. So that is why I said in the beginning that more the number of satellites that can communicate with the receiver, the better the prediction about the location. Or survey में, because we need more and more accuracy, so that means more and more receivers in view or in communication link, the better the prediction about the location of the receiver. So that is why we say that three satellites give you a location, but minimum four because you also need the altitude. So उस case में you need another satellite to give you your exact intersection in the other plane as well. So minimum four are required to give you exact coordinates of your location. And this process is called as trial iteration. See, so you can see on these two figures as well, that one satellite gives you a linear distance, and if you draw a circle, उसके center से every point on the circumference has the same distance. Similarly, you can imagine it to be like that. If it gives you linear distance, you can be anywhere. So exact location pinpoint करने के लिए, once you have more number of satellites, their trajectories keep on intersecting, और जो उनका intersection point होता है, ज़्यादा satellites का, that gives you exact location. This process is called as trial iteration. So this is the working principle of navigation systems. So just a few points. Satellite positioning is based on accurate data for the real-time location of each satellite and on very precisely kept time. इसमें time का component बहुत important है और ज़्यादा errors भी यहाँ पे आते हैं because you have different layers in the Earth's atmosphere और वहाँ पे diffraction होती है, the signals become distorted, उनका time change होता है based on that. and an error creeps in into your final measurements. तो उस वजह से the satellites use atomic clock जो they themselves are very accurate. अगर उनके अंदर कोई issue आता है obviously that is another story. लेकिन different reasons हो सकते हैं इन issues के, and we'll study later on कि how do you deal with those. It uses satellite signals, accurate time, and sophisticated algorithms to generate distances on ground receivers and thus provide positions anywhere on Earth. So satellite signals, accurate time, and sophisticated algorithms. Algorithms इसलिए use होते हैं because in the end, the output that you want, the user want, is the output of latitude, longitude, and altitude, and also integration with other systems. So पहले it takes a signal, calculates a distance in some other coordinate system. Later on, it transforms that into the geodetic coordinate system, जो कि हमारा coordinate system है of latitudes and longitudes. Satellite signals can also provide navigation data such as the speed and direction of mobile receivers. So it can use that data to give you uh, different things. उसकी speed दे सकता है. There's a live app on aircraft's location. Um, I don't remember the exact name, but if you write down uh, aircraft tracking or something, Google it. So you get a number of links. उसके ऊपर it gives you a whole GIS map of the exact location of different aircrafts which are in air at a particular time. उसके साथ साथ it gives you the speed as well, the ETA, estimated time to arrival. तो different information वो आपको देता है using the same data. उसके ऊपर algorithms run करके extracting different information and then giving you that exact information. Satellite orbits have been designed so that ground positioning can usually be determined at any location on Earth. We'll get to that coordinate system पे अभी जाके हम लोग उस पर बात करेंगे. In reality, 5 or more satellites are tracked, if possible, to introduce additional redundancies and to strengthen the geometry of satellite array. जितनी ज़्यादा satellites available होंगी, it's better. तो redundancy means कि you need minimum 4. Any satellites more than 4 are called as redundant, extra. But in real sense, they are needed. The more satellites your receiver can interact with, the better the results, the more precise the location. Spacing of GPS satellites is such that at least 6 satellites are always visible anywhere on Earth. So इनके जो orbits हैं, the orbits are defined for satellites. So if you're using the American GPS system, it has, I think, minimum 24 satellites, active satellites in space at all times. उनका जो आपस में, I think it's 60-degree apart, or geometrically they've positioned them in such a way, or उनके orbits fixed हैं. So from any location on the surface of the Earth, at least 6 satellites um, are there to be communicated with at any time. तो इस तरह से उनको fix किया जाता है. So how does the whole GPS process works? इसमें you have 3 different segments. Uh, you have the space segment, the control segment, and the user segment. Uh, the user segment, that is the receiver that you have, either mobile phone or a real-time GPS device, handheld GPS, या गाड़ियों के अंदर GPS होते हैं, inbuilt GPS होते हैं. So those are user segments. Then we have a satellite segment, the actual satellites in space, and then the control segment, how the whole information is received and then processed on the ground. उसके लिए we have those huge antennas to communicate with the satellites, and that is called as the control segment. So the space segment consists normally of 24 satellites operating in 6 orbital planes, spaced at 60 degrees intervals around the equator. So इनकी जो their location in space and the numbers and their orbits are arranged in such a way that you get minimum number of satellites in view at any position on the Earth at any time. Precise atomic clocks are used in satellites to control the timing of signals. The extremely accurate clocks and extremely expensive as well. Then you have the control segment, consists of monitoring stations which monitor the signals and track the positions of satellites over time. If you Google it, you can see where the control segments are for GPS, for GLONASS. उनके अपने मुल्कों में या अराउंड द वर्ल्ड उन्होंने इनको स्प्रेड किया हुआ है, so you can see that. And the user segment consists of receivers like we discussed. So what we are more interested in is the GPS receiver, the user segment, क्योंकि हमने उस data को use करना है for our serving purposes. So the GPS receivers range in ability from survey level millimeter to use in serving, or they can be used for navigation in which you don't need too much accuracy, but then you have the cost element. Obviously, the if you go for more accuracy, the instruments would get costlier. So if you get a handheld instrument for a few thousand rupees, जो actual GPS instrument है ज़्यादा accuracy वाला, that would cost somewhere in a few lakh rupees. तो इसमें फिर cost element आ जाता है. Marine navigation receivers have accuracy of 1 to 5 meters depending on what use they have. Over here, they have shown two different GPS receivers. One is a handheld GPS device, and the other one is a GPS rover. इस पे मैं बाद में आता हूँ. What is the whole functioning of the rover and the base station? लेकिन serving में, if you want to do accurate serving, the handheld GPS is of no use. ये जो दूसरी picture है on your left, इसमें actually वो use भी survey के लिए कर रहे हैं उसको, and it has much more accuracy and it can do the work a lot faster than your traditional instruments, theodolite or your leveling instruments. So GPS satellite constellation, just a little bit information about that, how they're manufactured, what is their size, just to have an idea of what they look like. Some GPS receivers are capable of tracking both GPS and GLONASS. I told you about that in the beginning. Increased number of satellites available to receiver can also reduce interruptions due to poor satellite geometry or by local obstructions. ये उसमें errors आ जाते हैं. We'll be talking about these in a bit. अच्छा, um, these companies or these organizations use different GPS signals. Obviously, the more traffic you have on a specific signal, uska accuracy would keep on dampening. उसमें usually in GPS they use two different frequencies, or one frequency is for the commercial use, the frequency that we use, and they have another frequency which they use themselves for military purposes and for space programs and everything. उस पे फिर traffic नहीं होती and they can use it with much less errors. Coordinate systems में, like I told you, कि at the end of the day, we as consumers want uh, the locations to be in latitude, longitude. लेकिन there's a whole process behind it. जहाँ से it takes the measurements of time, it then transforms it into distance, then it transforms it into a space coordinate system, then it transforms into a geocentric coordinate system, and then it gets transformed into the output, जो कि हमें नजर आता है, latitudes and longitude. उसके पीछे क्या हो रहा है? First, it gets information in the satellite coordinate system. So from the center of the Earth, एक coordinate system है for the whole satellite program. वहां से आपके पास आता है कि इसका orbit क्या था, और based on that आपकी coordinates क्या हैं. Then it transforms it into a geocentric coordinate system. अब geocentric coordinate system में और geodetic coordinate system में फर्क ये है कि in geodetic coordinate system you have the datum जिसको वो use करता है altitude को find करने के लिए, which is the mean sea level. Geocentric में नहीं है, it's from the center of the earth, लेकिन it's it's basically on the terrestrial earth surface. इसको further transform करने के लिए latitude, longitude and altitude, और to bring in that datum जो कि हम लोग use करते हैं, हमारे reference points हैं, उसमें transform करने के लिए transforms it into geodetic coordinate system. क्योंकि at the end of the day, what we want is we want latitude, longitude and altitude. So as users, what are the different errors that we need to take care of? जिस तरह हमने काफी errors पढ़े थे बाकी instruments में, इसमें they're a little bit different, but if you keep them in mind, that would tell you कि यार what is the right time to use a GPS instrument. and what is the right method to use it. So errors जो इसमें आ जाते हैं, first the satellite and receiver clock systematic errors. This is something that you can't do anything about. The control stations would be keeping track of it, और उसमें जो भी errors आएंगे, they would sometimes deactivate a few satellites because they have a few redundant satellites in space. कुछ को deactivate कर देंगे, which have a fault, or जो the satellites that would be active have to be 100% accurate. Then we have refraction errors. So, like I told you, कि since in atmosphere we have a number of layers, उसमें refraction, there's a process of refraction, the signals are slowed, um, so that introduces some errors. These errors can be reduced by scheduling nighttime observations. So this is interesting because during the day, you have sunlight and you have reflection of heat from the Earth's surface. And as it goes up, it takes the vapors, it takes ions, it takes impurities basically, um, to upper atmosphere. और जो layers हैं near to the Earth, they become pure at the night time. So इसलिए they say that during the night time, it's more accurate to use the GPS. So something which is a obstruction in traditional instruments, theodolite and your total stations, the instruments that you cannot use during the night time, उसमें एक hindrance है. This instrument is actually better if you use it at the night time. So it's very useful that some projects have so much work to do that if you just use them during the daytime, it really reduces the time during the day during which you can use it. So you can really pace up the work by using a GPS because you can use it round the clock, or you can do the same thing in pretty lesser amount of days. Okay, then we have multipath interference. So if you see this figure over here, they show that what's actually needed is that your satellite communicates directly with your receiver. So this is your receiver on the ground and this is the satellite. लेकिन if your receiver has physical objects near you, तो उसमें buildings आ जाती हैं, walls आ जाती हैं, basically surfaces which can reflect the signals and still retain the strength of the signal. उस केस में क्या होगा? Instead of direct link between the receiver and the satellite, the signal can reflect off a nearby surface and then reach the receiver. So what would happen would be that the time that the satellite is noting would increase. And that would mean the satellite would think that the object is at a greater distance, and it won't be able to track that it is because of multipath interference and not the direct communication. So this is something that you need to take care of as a user, that you do not select points, reference points which are close to physical objects. Obviously, in some projects, you would have this uh, obstruction or you would have this liability, but there are some workarounds that you can use to cater for this problem. Then we have positioning of satellites. You'll be covering a topic on triangulation with Sir Akbar, and you'll be studying this concept of strength of a figure. उसमें ये होता है कि if you select points which are close to each other, that would mean that in triangulation, the scheme that you would make would have angles which are acute or obtuse. But if you have angles which are between, I think, 40 to 70 degrees, something like that, in that case, your measurements are most accurate. Similarly, when working with GPS signals and coordinating with satellites, if the satellites are wide apart, it's a strong geometry. The chances of error are minimum. And if they are closer to each other, it's a weak geometry. Now, as a user, you cannot see okay, what is the location of the satellites. So the thing is, if you keep your instrument at a particular location for longer duration of time, the position of satellites would keep on changing because they're in orbit. If at one instant they have a weak geometry, at other instant the geometry would change to a strong geometry. And your receiver gives you the reading at the instant when the signal is strongest. So it would itself judge when the signal is strongest, and that would be due to different reasons. And one reason could be the strong geometry. And then it would give you at this instant, the signal was strongest, and this is the reading that you should take. So one way to make sure that you get accurate reading is to place the receiver at that particular station point for a longer duration of time. ये हम आगे जाके will cover this in the methods, but just keep this thing in mind that the more time you give a receiver at a particular station, the accuracy keeps on increasing. Then we have errors associated with the satellite orbital data. Again, this is something for the GPS or the GLONASS team to take care of. Then we have setup errors, centering errors. Obviously, अगर आप किसी एक point, if you need a location for a particular point, your receiver has to be exactly above that. And we saw over here, if you look in this diagram, that the receiver is placed on the tripod like before. So either it's a tripod or either it has a stand with it that we saw in this picture. So you can place it exactly above the station point and it can give you the right reading. So in that sense, we have centering. And then we have selective availability data access limit from the GNSS owner that this reflects back to the two frequencies that they use. So if they're limiting the traffic, so that means the strength of the signal won't be much and there would be errors. But again, these are the errors which you can't do anything about. So if your instrument has the option to use both GPS and GLONASS at the same time, then you can take care of it. Otherwise, you're stuck with this and you can only take care of the errors which are in your hand. For example, positioning of satellites. Keep the instrument at the location for longer time. Or errors such as multipath interference. Choose the points which are away from buildings or from other objects. Refraction errors. Again, you can do the process at the night time, or you can again place the instrument at the location for longer time. So these errors get cancelled out. So this is it for the first lecture of introduction. And in the next lecture, we'll start with differential GPS, a technique that we use in serving to take care of the accuracy problems. How to improve the accuracy of GPS. This is the main pain point of using GPS for serving. And we'll be studying different processes or methods that we can use to take care of that.